In this question, you're given that 6x square plus 2hxy plus 12y square plus 4x minus 2y plus 1 is equal to 0 represent a pair of lines. If that is so, what is the value of h? So we know the condition for general non-homogeneous quadratic in x and y to be a pair of lines. So the condition is nothing but determinant of 6h2 h12 minus 1 2 minus 1 1 has to be equal to 0. So this implies 6 times 12 minus 1 is 11 minus h times h plus 1, sorry, h plus 2 plus 2 times minus h minus 24 is equal to 0. This implies 66 minus h square minus 2h minus 2h minus 48 is equal to 0. So if you send all the terms onto that side, you get h square plus 4h 48 minus 66 plus 48 minus 66. So you get 66 minus 48 is 58, 68, 18 is equal to 0. So h square plus 4h minus 18 is equal to 0. So h has to be equal to, obviously you can see that this cannot be nicely factorized. And what is the value of h? Minus 4 plus minus root of b square minus 4ac, that is 4 times 18, 72 by 2. That is equal to minus 4 plus or minus root 88 by 2. That is equal to minus 4 plus or minus. So this is 2 root 22. So sorry, minus 2. So if you cancel it, 2 minus 2 plus or minus root 22. So this is the value of possible value of h. But the other condition which needs to be valid is h square greater than ab for the lines to be real. So h square has to be greater than a into b is 12 into 6, 72. So if you see the approximate values of h, so h is approximately equal to root 22 is something like 4.7. So minus 2 plus 4.7 is approximately 2.7. Minus 2 minus 4.7 is minus 6.7. And in both cases, you can see that the square of these two numbers are less than 72. So for neither of these values, h square is greater than ab. So what is the meaning of this? No value of h exists. No value of h exists for this equation to be a real pair of lines. Thank you.